Welcome back. This is an Aleks homework video on recognizing equilibrium from a sketch. So if you recall, equilibrium is when there is no more forward or reverse movement. So the amount of forward movement in a chemical reaction is equal to the amount of backward. So if you have a reversible reaction, products are being made at the same rate that reactants are being made. So when you do an equilibrium, you're interested in your K, and your K is essentially the rate or the speed. It's a constant that makes that reaction work. Okay, that explains that reaction well. So in this case, you're given not concentrations, but you're given molecules that you can see. And you can see which one is a reactant, which one is a product. And then you can compare products to reactants and check to see if the K that they gave you is what you see experimentally. So if you were to realize that reactants are going to go to products, so R is going to go to P, then your K is going to be equal to the concentration of products raised to the power of whatever coefficient those products are, divided by the concentration of the reactants. So it is P over R. You're not given a concentration here, but you are given molecules that you can count, and so you can look at them and say that, for instance, in this first one, the green circles here in a line are going to be your reactants, and the little triangle, brown triangle, is going to be your products. So how many products do I see? I see one, and I am going to divide that by my reactants, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count 9 there. And so my K, if this were at equilibrium, my K would be 1/9. So I look and see that they're saying that my K is 1/2, and 1/2 does not equal 1/9, so this is going to be not at equilibrium. If it is equal, then it will be at equilibrium. If it's not equal, then it's not at equilibrium. So let's look at the second one. The second one, I've got my products as being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my K, my products are going to be 10. My reactants are going to be 2. So 10 divided by 2 is 5. They are saying that it should be 9. Well, 9 does not equal 5. So this example is just not at equilibrium. Okay, let's look at the third example. The purple guys are my product. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So my K equals 8 divided by 1, 2, 3, 4. 8 divided by 4 is 2. And they're saying that I should have my K is 2. So if K is 2 and that's what I see, then this is at equilibrium. This is going to be one that happens to be at equilibrium. The last one here, my purple is product. 1, 2, 3, 4, 5, 6, 7, 8. My gray is my reactant. That's 2. And 8 divided by 2 is 4. And I look and they say that K equals 4. And since K equals 4 and that's what I see, then this, yes, is at equilibrium. Right? I hope that helps.